As we all know, food security has been an issue in our country for a long, long time already. Well, what is food security? Best of my understanding, food security means the availability of food for the people and also the safeness of the food for us to be consumed. And by that, we are from Group B here to present about our research on fish vaccination, which is a promising solution to enhance food security in the face of growing demand for seafood lovers. Well, this proactive measures not only lowers the risk of diseases, but also reduces the need for antibiotic treatments, which would lead to many, many benefits for our surroundings. Here in our presentation, we will include multiple methodologies, administration methods, and also the benefits and the usefulness of our research for the upcoming future. Stay tuned. Finally, that's done.
So now I'll be explaining what is really the problem statement of our project. In aquaculture, disease outbreaks represent a significant challenge, leading to heightened mortality rates and substantial economical losses. While vaccination stands as a critical measure for disease prevention, the current emphasis within the industry tends to lean towards more of chemotherapeutic treatments rather than vaccinations. Thus, our study aims to address this problem by delving into the optimization of fish vaccination strategies. So, by evaluating the different vaccination methods and their associated benefits, we seek to assess their impacts on fish health and overall aquaculture sustainability. It is imperative to recognize the pivotal role of vaccination in ensuring the economical stability, safeguarding the animals' welfare, and also to uphold global food security in the aquaculture system.
Next, let's talk about methodology. There are two things that we're going to discuss today, which are formulation and methods of administration. So first of all, let's start with bacterines. Bacterines are vaccines containing dead bacteria. They're easy to prepare, and it does not cause reversion to virulence. This makes it much more safer than live-modified vaccines, also known as live-attenuated vaccines. The method of administration can either be injection or oral administration. Secondly, let's talk about live-attenuated vaccines. So live-attenuated vaccines is suspension of attenuated live pathogens that are able to replicate inside the host. This makes it dangerous compared to bacterines because it might cause virus infection inside the host. However, it provides long-term immunity and it stimulates humoral and cell-mediated responses inside the host. The method of administration can either be injection or immersion. Now, let's look at the administration methods. There are three administration methods here, which are injection, immersion, as well as oral administration. Let's start off with injection. So injection involves oil-based vaccine, which is administered through intramuscular or intraperitoneal injection, where light anesthesia is required to reduce the stress experienced by the fish species. Secondly, immersion. So immersion is carried out by immersing the fish species in diluted vaccine solution. 30 seconds for small fish, 3 to 5 seconds for largest fish. The vaccine is absorbed through skin and gills, which has abundant antibody-secreting cells. And lastly, oral administration. So oral administration is carried out through feeding the fish with oral vaccines where they are encapsulated in alginate microspheres, or vaccine-fed artemia is being fed to the fish species. The artemia lipid prevents the vaccine from degrading, and this induces minimal stress and is more nutritious to the fish.
I will now share the information about the impact and usefulness of fish vaccination. First, fish vaccination reduces the need for antibiotic treatments by preventing the diseases before they occur. So, when vaccines effectively protect the fish from infection, there's less reliance on antibiotics for disease management. To elaborate, the presence of antibiotics even at low concentration, can cause changes in the ecosystem, such as nitrogen transformation, nutrient cycle, and degradation of organic matter. Next, fish vaccination helps in decreasing biomass losses. Biomass loss typically refer to the decrease in the total mass of fish due to various factors such as disease, predation, environmental stress, or management practices. To illustrate this, fish vaccination helps prevent diseases by stimulating the fish immune system to recognize and combat the specific pathogen, thereby decreasing the biomass loss. Moreover, fish vaccination contributes to increasing the fish survival rate. This is due to the vaccinated fish are equipped with the necessary immune defense to ward off the infection before they escalate, thereby minimizing the mortality rates and promoting overall fish health. This proactive approach not only preserves fish stocks but also enhances their resilience against environmental stress, ensuring higher survival rates throughout the production cycle.
Going on to the next point, the use of vaccination in fish able to boost growth. With vaccination, fish is less likely to get a disease as vaccine induces a long-lasting immune response. Fish can allocate more energy towards growth rather than combating an infections that will lead to decrease in appetite and hinder the growth of the fish. Fish is also less likely to experience stress associated with diseases, which can suppress the immune system. Last but not least, low expense in the long run. Vaccination minimizes the need for costly treatments such as antibiotics, as it prevents diseases before they occur. It's more cost-effective than treating outbreak of diseases, as it might result in losses which will have a big impact on the income of the fishery. Vaccinated fish are less likely susceptible to diseases, resulting in lower mortality rates. By improving survival rates, vaccination helps maintain a stable and productive fish population over time, which is economically beneficial. As for future suggestion, we are looking towards DNA recombinant vaccine. These vaccines are created by introducing specific DNA sequences encoding antigens from pathogens into host organism, stimulating an immune response against the targeted pathogen. This vaccine is still not commonly used yet, as it is quite costly because biotechnological processes are needed in making this vaccine, and it still requires extensive testing to evaluate its effectiveness on the fish immune system. All in all, we believe that fish vaccination plays an important role in food security as it helps to meet growing global protein demands. That's all from us. Thank you. Bye-bye.